Picture this. Your weather app promises a hot day, one you can plan around, and then you step outside and the air feels like it is pressing down on you, far worse than the number on the screen suggested. That gap between the forecast and what your body actually feels is not just in your head. It is showing up again and again in city after city, summer after summer. Have you ever wondered why the hottest days of the year seem to keep breaking records by margins nobody predicted, instead of just edging past the old ones? Rewind to a summer in the Pacific Northwest, a corner of North America famous for mild gray weather, not desert-level heat. For a few days, temperatures spiked so high that meteorologists watching the readings assumed their instruments were broken. They were not. The region briefly got hotter than cities in the middle of the desert. Now think about Western Europe. Heat waves in 2003, 2010, and 2018 each felt like the worst anyone had seen. Then 2022 arrived, and it was worse again, part of a season connected to more than 60,000 heat-related deaths across the continent. The pattern was not limited to one continent. The Amazon basin saw record-breaking heat strain, a region that usually stays humid and cool under its own canopy. And southern Africa endured a multi-year drought, made worse by an especially brutal heat wave. Heat is also a strangely quiet killer. Unlike a hurricane or a flood, it rarely makes for dramatic footage of collapsed buildings, so its death toll tends to be undercounted and forgotten almost as soon as the temperature drops back down. Climate scientists even have a specific term for events like these: record-shattering extremes, meaning they do not just nudge past the old record, they blow past it by a margin so large that, statistically, it should barely ever happen. So here is a question worth sitting with. Are not we supposed to have supercomputers for this? Entire agencies run climate models meant to tell us what is coming. A climate model is essentially a virtual version of Earth, built from the physics of air, ocean, and land, run forward in time on a massive computer. Scientists do not just build one, they build dozens from different institutions and compare notes. For decades, that approach has done a genuinely good job on the big picture, tracking how much the planet is warming on average, year after year, with real accuracy. But predicting the average is a different problem than predicting the sharpest extremes. Knowing the average height of everyone in a stadium tells you almost nothing about how tall the single tallest person in that crowd will be. And extremes are exactly what hurts people. Not the average summer day, but the handful of days each year when hospitals fill up, power grids strain, and crops fail all at once. So here's a question worth sitting with for a second. Why would models that are genuinely good at predicting average warming struggle specifically with the hottest, most dangerous days of the year? Part of the answer is that the hottest days are not created by one simple cause. They come from a messy tangle of local conditions colliding at the same time. Picture a giant lid of high-pressure air parking itself over a region for days, trapping heat underneath the way a lid traps steam over a boiling pot. Meteorologists call this a blocking pattern, and it can turn a warm week into a record-breaking one. At the same time, when soil dries out completely, it stops evaporating moisture that would normally cool the air near the ground. All the sun's extra energy goes straight into raising the temperature instead, and the effect can snowball. On top of that, the jet stream, the fast river of air circling high above our heads, sometimes gets stuck in a wavy, stubborn pattern instead of flowing smoothly. When that happens, the same patch of hot air can sit over one region for days, or even weeks instead of moving on. Ocean temperatures thousands of miles away can tip the scales too. A well-known Russian heat wave was linked to unusual sea surface patterns in the Pacific, the same kind of connection scientists suspect nudged several recent extreme heat events in the northern hemisphere. Here is a genuinely strange twist. Some climate models have the opposite problem, running a little too hot on average, overestimating overall global warming compared to what has actually happened. And yet, even those same models still underestimate the sharpest, most dangerous extremes. Getting the average roughly right and getting the extremes roughly right turn out to be two completely different challenges. there is an even more counterintuitive piece of the puzzle. As countries like China have cleaned up their air, cutting the haze-forming pollution that used to block some sunlight, that same clean air has let more heat reach the ground, quietly adding to local warming trends. Scientists have a name for the strange pattern buried in all this. In many regions, the very hottest days of the year are warming much faster than an ordinary warm summer day, as if the top edge of the temperature scale is stretching away from the rest. Measuring that stretch properly meant rebuilding the planet's temperature history almost day by day, using weather stations, satellites, and ocean buoys, stitching it all together back to the late 1950s. Then came the real test. Take that 6-decade record of what actually happened, and line it up against dozens of separate model simulations built by different research groups, some running at far higher resolution than others. To make sure any pattern they found was not just noise, researchers reran the statistics on each region roughly 10,000 times over, reshuffling the numbers again and again to see if the trend held up. It did. So which one do you think won? Cold, hard reality, or the sophisticated models designed to predict it? The answer surprised even the people who ran the numbers, and it is not a comfortable one. If stories like this, real scientists quietly checking whether our warnings about a changing planet are actually keeping pace with reality, are the kind of thing that hooks you, hit subscribe, because we track down a new one every week. Now, back to the part nobody had actually nailed down with hard numbers, and why it matters far beyond weather trivia. Major climate targets, including the internationally agreed threshold of 1.5 degrees Celsius of warming, were built using the average projection across many models. Power grid planning, hospital preparedness, insurance pricing, even how high a seawall gets built, all of it leans on these same model projections being roughly right about what is coming. A team of researchers pulled together that entire 6-decade temperature record and compared it directly against a huge batch of climate model runs, looking specifically at how the hottest days of each year behaved compared to a merely warm one. Western Europe turned out to be the clearest example of all. The hottest days of the year, there are now warming at roughly twice the pace of an average summer day, the trend sitting directly behind those escalating heat waves of 2003, 2010, 2010, and 2022. Similar danger zones showed up far beyond Europe: central China, the Arabian Peninsula, eastern Australia, Japan and Korea, southern South America, and even the far northern reaches of Canada and Greenland all showed the same runaway pattern. So how badly did the models actually miss this? Averaged across the planet, the models underestimated the areas where this extreme heat trend was accelerating fastest by roughly a factor of 4, and they only managed to catch about a third of the genuinely significant hotspots that show up in the real-world record. In some places, it was worse than simply missing the mark. In southern South America, the Arabian Peninsula, and the Canadian Arctic, the real-world trend landed completely outside the full range produced by nearly 50 different model simulations, not just near the edge of what they predicted, but beyond all of them. You might assume the fix is just more computing power, but even the newest high-resolution simulations and versions fed with real historical ocean temperatures instead of estimates barely close the gap. Zoom out to the entire planet and the mismatch holds up. Roughly 16% of the land area showed a genuinely significant hot extreme trend in the real-world record, while the models only flagged about 10%, and that gap widens further at the very strictest statistical threshold. Newer efforts are trying to close that gap, from next-generation super high-resolution simulations to machine learning systems trained to spot the exact physical patterns older models miss. So far, none of them have fully cracked it. The researchers are careful here, and this is the one honest caveat worth remembering. This is not proof of one single tidy cause. It is a tangle of interacting factors: drying soil, stalled high-pressure systems, shifting pollution patterns, and untangling exactly how much each one contributes is still an open scientific question. What is not in question is the practical stakes. If the most damaging extremes are already arriving faster than the model averages behind our climate targets suggest, then leaning on those averages alone risks underestimating the exact kind of event most likely to overwhelm a hospital, a power grid, or a city's water supply. You can find the full study with every region, every model, and every number linked in the description below. So next time your phone promises a warm day, remember that reality has a documented track record of showing up hotter than expected, and now we finally know by roughly how much.